Greetings, my name is John Gabriel and this is a new calculus channel. And since I've never done a video on continued fractions, I'll explain to you what these mean. So, what is a continued fraction? Right. Well, it's really, in many aspects, in fact, in its central aspect, it's identical to the Euclidean algorithm, which finds the greatest common divisor. Okay. Oops. Greatest common divisor. So we see here that the greatest common divisor is 6. Now, that's because we say 48 divided by 18 is 2, and there's 12 left, right? So it's 2 times 18, which is 36, plus 12 is 48. That's this step. Then we want to measure this divisor with the remainder, and it measures this divisor one time with a remainder of 6, and finally 6 measures 12 exactly 2 times. So, therefore 6 is the greatest common denominator, or greatest common divisor actually, I'm sorry. And now if we did it using continued fractions, which is on the side here, we'd say 48 divided by 18 is 2 and 12 over 18. And of course 12 over 18 is the same as 2/3, isn't it? Like that. So, but we don't need to convert this to 2/3. We could just leave it as 12 over 18. If we convert it to 2/3, the rest of the calculations become simpler. But we'll just leave it as is and say that this here is equal to 2 plus 1 over 18 divided by 12, because 1 over 18 divided by 12 is the same as 12 over 18. And so that reduces to 2 plus 1 over 1 plus 6 over 12. And if we rewrite that like that, we end up with this final form, okay? And you'll see that the quotients are the same as these, okay? So that's basically what a continued fraction is all about. And any fraction that you take, any fraction P over Q, has a finite continued fraction representation. There are some ratios, however, which do not. For example, the ratio of square diagonal to square side doesn't have a finite representation, but it does repeat after a certain stage. So if it repeats after a certain stage, then is it worthwhile? Okay, so now let's see if it really is worthwhile. Let's grab some space here. Well, actually, before I leave this, I want to show you something else. The idea with these continued fractions is that you can get back to the original very fast. Okay, so if you start with this part here, we get a different color. If you start with this part here, 1 plus a half, you simply multiply that by 2, so you're actually getting 2 over 2 plus a half, which is 3 halves, and because it's inverted, it becomes 2 plus 2/3, and you're done. Okay, you're back to the original fraction. You could go one step further and say that's the same as 6/3 plus 2/3, and so that's 8/3. Okay, and that's what you have over here. Now let's look at the continued fraction for this special ratio here, which has no measure. Okay, so don't say. So the continued fraction here would be something like this: 1 plus 1 over 1 plus 1 over 1 plus, and let's just say a half here, okay? Or actually, I think it is a half, not too sure of that. Well, we'll see in a moment. But if you decide you want to find the value there, I think it's actually 1. Okay, but anyway, the idea is that you'll use the same process here. You'll basically add these by flipping them, which is very easy until you get to a good approximation, which would be 1.414. So I don't really remember what the exact representation is, but that's basically it. Okay, so this is my first video on continued fractions. They're not really that remarkable. They're not really that useful, even though some say they're used in encryption, RSA encryption, and other things like real number approximation, which is absolute garbage because there's no such thing as a real number. So if you're not already a subscriber to my channel, become one, okay? This is my channel. You can come here, click on any one of my videos, hit the join button, and become a member, because if you're part of members, you get access to special information that I don't normally share with the public. It only costs €4.99 a month. It's a cup of coffee, and you learn more than you've learned in all your school and university years. I'm John Gabriel. This is a New Calculus channel. Till next time, goodbye.